let me quickly get into this session. So what do you see on the screen? Just quickly let me know so that I know I'm sharing the right screen. Chapter 14, right. So hypothesis testing is something that we covered. Now coming back to this, I'm going to start with, so we are also going to go through this design of experiments in the upcoming sessions. Okay, we completed this hypothesis testing, and this hypothesis testing and correlation regression are very important topics in analyze phase. And now let me get into correlation regression. Correlation. How many of you, what do you understand by correlation? Okay, let me see something in the chat box. What do you understand by correlation? You can type in few simple words, that's enough. Okay, two factors relate to each other, fantastic, affecting each other. So correlation is one variable is related to the other. And I'll give you many examples on correlation, but I wanted to help you to understand that the relationship can be strong, the relationship can be weak. Any relationship can be strong, any relationship can be weak, or there need not be any relationship at all. So how is your relationship with your spouse? Please put it in the chat box. Strong? It can be strongly positive, it can be strongly negative also. It is so strong that we keep fighting with each other strongly. Or if it is so strong that we love each other every day. Or she does her job, I do my job, there is no relationship. I don't care about her, she doesn't care about me. Okay, all of you please give me a smiley in the chat box, because this is an intricate, delicate, and in-depth topic. There'll be some formulas, don't get scared about formulas, and we will make it as interesting as possible. Okay, and as useful to possible. When you leave this session, you will remember correlation and regression for lifetime. All right. And those who have come jointly, don't forget to register for the upcoming session, where you will get an internationally, if you want an internationally recognized certification, please register in the link for the upcoming webinar. Okay. Now, this correlation regression part of the analyze phase is the first example that I give you is study hours and marks. The more hours you study, the more marks you get. Do you agree with this? Yes or no? If you agree with this, if you strongly agree, you type +1. If you strongly disagree, you type -1. Or if you feel it doesn't matter, you give a 0. Or you can give somewhere between -1 to +1 also. I agree to some extent means you can give 0.8, or I agree very less, you can give 0.4. You can choose any number between -1 to +1, 0 being no marks and that study hours not related, or +1 being 100%. Yes, if I put more number of hours, I'll get more marks. Or if I put more number of hours, I'll get less marks if it is negative. Okay. So generally, when it was done for my son, it was like maybe up to 9 hours of study. The number of marks they had studied on a few students, they said the number of hours that is put and the marks that they get. If they study for 1 or 2 hours, maybe they get only around 30%. But if they study for 8 to 9 hours, maybe they are getting anywhere between 70% and 90%. So this is just to tell you this, there is a relationship between two variables. There is a relationship between two variables. Okay, so correlation, it can vary positively. This is called perfect positive correlation. All of you type PPC in the chat box. Perfect positive correlation. Or it can be perfect negative correlation. For example, if the temperature increases, the pressure decreases. In a closed cabin, if the temperature increases, the pressure decreases. Or the pressure increases. I don't know if it is a closed container. Perfect negative correlation, PNC. I'll tell you what is perfect, okay? Don't worry about that. I'll tell you what is perfect. And zero correlation means no correlation. It doesn't matter whether it rains or it doesn't rain. For me, my marks is not going to get affected. There is no correlation between the rainfall and my marks that I get in the examination. If this is clear, type SC, super clear in the chat box. We will go to the next step. Every step I'll be asking you. Thank you very much. Now the question, ready for the question and answer. All of you be ready. What is the primary purpose of correlation analysis in the analyze phase of Lean Six Sigma? To establish the effect of independent variable, to determine the relationship between two or more variables, to predict the future values of dependent variables, and to establish the significance level of data. Quickly put in the chat box. Okay, send a lot of chocolates, send a lot of pizzas, burgers to those people who have typed B. Well done, it's a good job, done. So correlation, I just wanted to help you understand through this sort of explanation. Nobody would have done, but I would want to help you understand this correlation through a Venn diagram. Imagine two circles. Imagine two circles. Now this is the correlation of a number which is 0.5. And imagine a circle that your marks and the study hours of two different circles, and they are related to some extent. Sometimes even if you study excessively, you're not going to get marks, or if you don't study excessively, you might get more marks, but there is some sort of a relationship. Okay, this is correlation, imagining about 0.5. Now, if you see minus 0.5, you will see again the same type of overlap, but then the equation is different here. Don't worry about the equation, don't worry about the other things, but I just wanted to give you a mental thought process on how you understand the correlation. This is like husband and wife relationship, okay? Like the earlier thing, husband and wife strongly related, they agree with each other, and this is husband and wife negatively related, okay? They don't agree with each other on certain things. Now, if there is no perfect relationship, if one is not dependent on another, there are two independent circles, okay? When something happens to husband, nothing happens to wife, type of a thing. They are not related. It's not husband and wife, but it's one male and female. They are not related to each other, so nothing affects what he does. So far, if you found it simple, interesting, useful, awesome, fantastic, put in the chat box. I also want some inspiration. I also wanted to understand how it is going on so far. I'll take it to the next level now of understanding. I'm going to share with you a link where you can simulate yourself. I'm going to share with you the link that you can simulate. Okay, thank you very much. Now, the same thing is applicable. So if it is perfect positive correlation, they overlap on each other. They overlap on each other. Everything is agreed. If he agrees, she also agrees. If you study more, you get more and more. The more and more you study, the more and more marks you get. Okay. Similarly, for the negative also, disagree 100%. They are overlapping. That's how you imagine this. Now, I wanted to give you, how many of you want to do the simulation yourself? I'll give you a link to do the simulation. Type want in the chat box. I'll give you the link. How many of you want to try to do the simulation yourself? So I came across this, and courtesy to this website, okay, let me share the link of this so that you'll be able to. I'll just stop the chat and share this link, okay? You can click on this link. You can have this link handy with you later, but then I'll show with you what you see in this link. Now, in this link, you see a simulation. Okay, I'm sorry about this. Just a moment. And there is a top bar here. Okay, the correlation you can adjust here. Now, if you see here, if the correlation is completely negative, you see these triangles are, these circles are overlapping with each other. This is perfect negative correlation. And as and when you increase this, let's say this is, I showed you minus 0.5, right? So if you come to minus 0.5, you see that they overlap to this extent, right? This is just for you to imagine to understand correlation. If you see, if it becomes 0, that means these two circles do not overlap at all. Okay, they don't overlap at all. That means they are mutually exclusive. Statistically, it's called mutually exclusive. I don't want to scare you with the hi-fi terms. Okay, I'll give you this link inside our resources also. Don't worry if anybody missed this link. And see, this is towards positive correlation. Okay, one increases, other also increases. And then this is perfect positive correlation, which is So if this was helpful, interesting, useful, fantastic, awesome, you can put it in the chat box just for you to have a feeling of the simulation. Yep. Coming back to our presentation. Awesome. Thank you very much. Hope you enjoyed it. Hope this was interesting. Fantastic. With that said, we'll get into a question answer session now quickly. In the correlation analysis, if two variables have a correlation coefficient of -1, this means what? Even before I give the options, I wanted to see in the chat box what all is that you put. If it is -1, what is that? Perfect negative correlation. Fantastic. It's not mutually exclusive. It is perfect negative. So they have no correlation. They are perfect positive correlated, perfect negative correlated. And the right answer is, now I want all of you to type the right answer. All right. So this is perfect negatively correlated. Whereas if the correlation coefficient between two variables is 0, what does it indicate? Let's see in the chat box. What does it indicate? Zero correlation, no correlation, right? There's no correlation. Fantastic. So these are the options that is available, and which is the option that you choose? Okay, there is no linear relationship between the variables. All right, thank you very much. Let's get into further detail of correlation coefficient. Now we said that -1 is perfect negative correlation, +1 is perfect positive correlation, and the stronger is on the positive. Larger the number, the stronger it is, whether it is negative or positive, right? And the weaker it is if it comes close to 0, whether it is negative or positive. So far, if it is clear, on a scale of 1 to 10, please give me a 9 or 10 if it is super clear. Fantastic. Those who missed this, make sure that you attend my upcoming webinar where you will get an internationally recognized certification. I'll tell you how to get that. Okay, so the number, it is denoted by R. The correlation coefficient is denoted by the number R. All of you type the small letter R in the chat box because this is your takeaway today. When I ask correlation coefficient, what is the symbol for correlation coefficient? You should type small r in the chat box. And we have already said, now all of you send a scary emoji in the chat box. This is how the formula. Don't remember this formula, okay? Those of you who are scared can send the scary image in the chat box, okay? So this is how it is calculated. I'm not going to explain this. The R is this formula, okay? But a lot of softwares will automatically calculate these numbers. So don't worry about that. Excel has its features. Minitab has its features. SPSS has its features. There are many statistical. Now, just to explain it further, reinforce it further, if it is towards the center, there is no relationship. Towards the left, we call perfect negative and perfect positive towards the right. And in between, there is a moderate negative relationship here and moderate positive relationship here. Okay, the same thing just reinforced in different languages. So the question here is, in Lean Six Sigma, which of the following correlation coefficient indicates the strongest relationship? So minus 0.5, 0, minus 0.9 and 0.7, which indicates, this is a very tricky question. Don't type ABCD, type the number, whatever that you see, because this is a little tricky question. I want you to understand this properly. Most of you will make a mistake of typing 0.7, okay, because it is positive. No, the correct answer is minus 0.9, because minus 0.9 is more stronger than positive 7. Okay, how many of you understood this? Type US in the chat box. Understood in the chat box. Very, very important to understand. I'm asking the question, in Lean Six Sigma, which of the following correlation coefficient indicates the strongest relationship? This is strong related, negative strong relationship. Strong negative relationship. So the correct answer is minus 0.9. Covariance. I wanted to introduce you to this word called covariance. Don't get overwhelmed by this word, covariance. Covariance and correlation coefficient are almost same, but correlation coefficient actually gives the strength and the direction of the relationship. I'll just introduce this to you, but don't, you can read this in notes and understand it, because in this online session, if I start explaining this, you will feel very bored. I don't want you to feel very bored. I'll share this presentation so that you can understand this. Covariation is precursor to correlation. A measure of how two variables change together serves as a precursor to correlation. It reveals the joint variability and the direction of the linear relationship between variables. Okay, the key points to remember is positive and negative covariance and covariance and independence. So if it is towards zero, it is called independence actually. Positive and negative covariation is the direction that we have seen. Either one increases, other increases, or one increases, other decreases. We have seen that in length. So to that extent, I want to explain and leave it. But then I wanted to let you know that covariance measure the degree to which two variables change. If both variables tends to increase or decrease simultaneously, the covariance is positive. If one increases while other decreases, it is negative. However, covariance is unbounded. I'll explain to you what unbounded is, okay? Correlation is bounded between -1 and +1. Covariance is between -infinity and +infinity. That is what I wanted to communicate. While the covariance indicates the direction of the relationship, correlation allows for easier comparison between different variables pairs. Okay, though I have explained this, there is no need to remember or assimilate or digest this. It is just for the sake of knowledge. So leave it at that point in time. I wanted to actually give you some snapshots between the covariation correlation in terms of its meaning. As you said that if you see it's an indicator on how two random variables are dependent. Correlation is how strongly they are related. How strongly they are dependent, how strongly they are related. Now, here, the relationship, if you see that, we can detect correlation from covariance, but correlation provides a measure of covariation on a standard scale. This is quickly, I'm explaining to you, and I'll give you all these notes, don't worry. And covariance is, as I said, the value is ranging between -infinity to +infinity, whereas correlation is +1 and -1. And the scalability, covariance is affected, whereas correlation is not affected by changes in the scale or multiplication by a constant. Okay, and lastly, the units, inflation and deflation. Covariation has a definite unit as deduced by multiplication of two numbers and their units, because we saw the formula of the covariance, and correlation is unitless absolute -1 to +1. I will leave you at this. I don't want to explain because we are not in the statistical class. Now, all of you say goodbye to these explanations. Okay, don't get scared, don't get overwhelmed. All of you say GB, goodbye to this, and I will introduce you. Okay, because I don't want you to get scared, overwhelmed by this correlation, because it's very simple. We just trying to find out the strength of relationship by one number between -1 to +1. But I gave you a little bit of in-depth for a few minutes, just that you should know. Okay, now the point here is I wanted to help you understand that correlation does not mean causation. Because, for example, if the ice cream sales are increasing and there is a sunburn rate, okay, because of the sun, the ice cream sales will increase, and because of the sun, the number of sunburns will increase. Can you say if ice cream sales increases, the sunburn rate will increase? Can you say? All of you type no in the chat box. They are not related. If you put a graph between number of volume of ice cream sales and the number of sunburn rate, they will be perfectly related. Okay, but the cause is the sun. Okay, the cause is the temperature. Okay, the cause is the temperature that is allowing. So correlation does not mean causation. If this is clear, type super clear in the chat box. Okay, the ice cream sales, if you see, is going here, and the sunburns rate is also here. Both of them are perfectly, if you put the graph, because the software will not know that. It will say there is a perfect relationship. All right, okay. So correlation versus regression. I wanted to introduce you the word called regression now. How many of you know about regression? Type K, no, W. If you don't know, type NO in the chat box. How many of you know regression? If you know about regression, type K, no, W. If you don't know about regression, type NO in the chat box. Depending upon how much you type, I will also pace the lessons here. Okay, let me get back to here. Correlation is just, showing. Regression is just a simple line that you draw, and every line has an equation. Every line has an equation. Now, my question to you is, if that line is called as a regression line, you're trying to find out a relationship between these two variables. using a line. What is the formula for the line, equation for the line? Okay, this is not a very, I mean, I don't expect everybody to say. How many of you remember the high school formula, equation for a straight line? Y is equal to mx plus c. Himanshu, great. Y is equal to mx plus c or mx plus b or whatever it is. What is the m here? What is the m here? Slope. Okay, what is the c here? Let's see how many of you answer. What is the c here? A constant. Intercept, y-intercept. Okay, fantastic. I will just leave it like this. Okay, I will leave at that. I don't want to overwhelm people who are scared about mathematics because they'll drop out of my webinar. Okay, so I will explain to you using a simple chart here. So the heavier the animal, whether it is positive correlated, the speed of the animal versus the weight of the animal, is it positively correlated or negatively correlated? You can type PC or NC. Negatively correlated. What it means is, if the animal is very heavy, then the speed will naturally decrease. Right? Okay, so I've given here the Rhino, which is 1.4 tons, okay, versus the cheetah, which is just 60 kgs. Okay, which can run at about 110. I can't run at 110. Okay, I'm also 60 plus kgs. Okay, 60 to 65. This is only talking about animals. Okay, so we are just trying to bring in a relationship here. We are trying to bring in a relationship. The weight is put on the x-axis and the running speed is given on the y-axis, and we see the Rhino, which is 1400 kgs, can run only at the speed of something like 45 kilometers per hour. Okay, whereas the cheetah and the pronghorn or deer, a type of antelope, which can run something like 100 or 110. Okay, look at that. This is running at 100 and cheetah is running at 110. So cheetah can catch the antelope or the deer, right? Okay, so if you found this example interesting, useful, you can put it in the chat box. You know, I've taken efforts to put all this together for you so that you don't forget. So that when you go into deeper relationships, something simple that you will remember. Because if I just put dots, you might not relate so well. So I will just put here. So the equation is like this. Okay, don't get overwhelmed by this. You have seen this is a positive correlated, and this is called as a change in y. The change in y, for 1 unit increase in x, there is a change in y. So you all said y is equal to mx plus c. I put a plus bx, whatever is that. So the question here is this. In a simple regression model, what does the slope of the regression line represent? Okay, in a simple regression model, what is the slope of the regression line? Intercept of the line, strength of the correlation, the change in the dependent variable for 1 unit increase in the independent variable, and the degree to which it is. Okay, so the correct answer is the change in the dependent variable for 1 unit. That's what we saw just in the slide before, right? Just that's what we saw in the slide before. Okay, so there is a simulator, regression simulator, that link that I will share with you so that you can also see the simulation. I will share it with you in the resources. The regression line is something like this. Okay, this is also called residuals. Whatever is away from this line, the deviation from this line, it's called as residuals. All of you type RESIDUALS, residuals. Okay, this is something that you can take in the notes. Don't get overwhelmed again. This is just the difference between that predicted line and the individual point, the distance. Okay, this is called as a residual. Okay, now I'm just introducing the word. This is also called as a error term. It's called as error because it is deviating from the perfect line. It's supposed to be on the line, but the actual result is deviating. So the calculation is something like this. All of you don't get scared, but I'm just introducing this calculation because you should know this residual, the estimate of slope, how it is calculated. Okay, this is just for the academic interest. Okay, so how many of you want to see a 3-minute simulation video, which is very interesting, that I have taken for you? type BIO, bring it on in the chat box. In 3 minutes, you will see a wonderful explanation of this. And if you stay till the end, I'll give you this video also. Okay. Okay, so I'll go off the video so that you pay maximum attention inside this video. Okay.
The correlation coefficient, also called the Pearson correlation, is denoted by R. It measures the strength of a relationship between two variables as a value between -1 and 1. A correlation coefficient closer to 0 indicates there is no correlation. If it's closer to 1, it indicates a strong positive correlation, meaning that when one variable increases, the other proportionally increases. If it's closer to -1, then it indicates a strong negative correlation, which means as one variable increases, the other proportionally decreases. There are different implementations of the correlation coefficient. When we are talking about a linear relationship, we use the Pearson correlation. It ratios the covariance between the two variables and their product of the standard deviations. However, the covariance is not interesting on its own. Instead, we use it for metrics like the correlation coefficient. And here are the key points. When R approaches 0, it indicates there is no correlation. If R approaches 1, it indicates a positive correlation. If R approaches -1, it indicates a negative correlation. Now let's talk about the coefficient of determination, which squares the R value. The R square measures any impact that the input variable has on the output variable and scores it between 0 and 1. It indicates how predictable the relationship is between the input and the output variable based on the proportion and the variation between the two. Notice that as the R approaches -1, the R square approaches +1. This should not be surprising, as when you square a negative number, it will become a positive number. This is useful as the R square is agnostic to the positive or negative nature of the correlation and just establishes if there's a relationship altogether. And these are the key points. As R square approaches 0, it indicates a weak relationship. As R square approaches 1, it indicates a strong relationship. One last footnote here. You might recall in the last video where we talked about the sum of squares, which very much play a role in the Pearson correlation. If we want to take a linear regression from a different data set, say the training data set, and apply it to the test data set, take the sum of the squared residuals and then produce a line simply reflecting the average of the y values as if we didn't use the input variable at all for prediction. We can then set the linear regression against using a simple average to see if the linear regression does anything productive at all. Subtracting this ratio from 1.0, this gives us the R squared.
All right, if you found this video useful, interesting, just type useful and interesting in the chat box. And I wanted to introduce you to the concept of simple linear regression and multiple linear regression. We'll spend another 5 minutes together, okay? So simple linear regression is your experience. Based on your experience, you get your salary, okay? The more is the experience, the more is your salary. But salary does not depend only on your experience. It might be dependent on your degree that you have, your experience, plus your age also is a criteria for your salary. If this is clear, type SC, super clear in the chat box. Okay, so when multiple variables are influencing one outcome, this is called multiple linear regression. Okay, so I will just leave it at that. And then I wanted to ask you a quick question here. So which type of regression would be most appropriate when predicting a continuous outcome based on multiple independent variables? Okay, simple linear regression, logistics, multiple linear regression. And the answer is very straightforward, whichever is that I have explained here. Okay, so multiple linear regression is this. That's why I just introduced the multiple linear regression. And another question is, which statistical tool is most commonly used to visualize the relationship between two variables? histogram, scatter plot, control chart, and box plot. Okay, this is also a very simple question, which is a statistical tool that is used to visualize the relationship. Yeah, absolutely. That's a scatter plot. And I have explained about the coefficient of determination in regression analysis. Okay, if you had heard this video in depth, you would understand which of these following statements is true about the coefficient of determination. Okay, because R is a coefficient of correlation and R squared is a coefficient of determination. It ranges from -1 to 1. It explains the percentage of variance in dependent variable explained by the independent variable. It indicates the direction of the relationship, and it has no relationship to the fit of the regression model. Okay, this is, if you've understood the video, yeah, B is the right answer. Okay, it explains the percentage of variation, because whatever that you have answered as A is for correlation, but for regression, it explains the percentage of variation. Now, how many of you want to see a quick 3-minute video on linear regression? I should have showed this video first. I'm sorry about that, so that you will get the nice connect. But anyway, it doesn't matter. Type BIO in the chat box. Just 3 more minutes and we'll wind up for today. I will share with you all the presentations and the material which I promised to give. Okay, I hope you are all finding it interesting, useful, these videos, right? I just made it 3 minutes so that you're not too much overwhelmed. Okay.
Linear regression is a statistical technique for modeling the relationship between an output variable and one or more input variables. In layman's terms, think of it as fitting a line through some data points as shown here, so you can make predictions on unknown data, assuming there is a linear relationship between the variables. You might be familiar with the linear function y equals mx plus b, where y is the output variable, also called the dependent variable. You may also see it expressed as f of x, the function of the input variable. X, on the other hand, would serve as the input variable, also called the independent variable. It's likely you'll see the coefficients m and b expressed as beta 1 and beta 0 respectively. So what do the m and b coefficients do? The m, or beta 1 coefficient, controls the slope of the line. The b, or the beta 0, controls the intercept of the line. In machine learning, we also know it as the bias. These two coefficients are what we are solving for in linear regression. We can also extend to multiple input variables, so x1, x2, x3, with beta 1, beta 2, and beta 3, and so on, acting as slopes for each of those variables. In these higher dimensions, you would visualize the linear regression as a hyperplane. So how do we fit the line to these points? Well, you'll notice that there's these differences between the points and the line, these little red segments. These are called residuals. They are the differences between the data points and the predictions the line would produce. Take each of these residuals and square them. These are the squared errors, and notice that the larger the residuals are, the more amplified the area of the squares are. If we total the areas of all of these squares for a given line, we will get the sum of the squared error, and this is known as our loss function. We need to find the beta 0 and beta 1 coefficients that will minimize that sum of squared error. The coefficients can be solved with a variety of techniques ranging from matrix decomposition to gradient descent, which is depicted right here. Thankfully, a lot of libraries are available to do this for us, and we will deep dive into these topics in other videos. To validate a linear regression, there are a number of techniques. Machine learning practitioners will often take a third of the data and put it into the test data set. The remaining 2/3 will become the training data set. The training data set will then be used to fit the regression line. The test data set will then be used to validate the regression line. This is done to make sure that the regression performs well on data it has not seen before. Metrics used to evaluate the linear regression vary from the R-square, standard error of the estimate, prediction intervals, as well as statistical significance.
All right, thank you for bearing with me so long, because this is a very, very delicate topic, and if you found this session interesting, useful, fantastic, awesome, put it in the chat box. I'll draw some inspiration from your comments.